The final way we're going to teach you about solving analytic limits, that means limits where you just have the equation and you're supposed to find it, is for difference quotients. And just to remind you, difference quotients are very much related to the slope. In fact, they are the slope. Think about that word difference. Difference in math means subtract, the difference between two numbers or two values. Quotient is obviously division. So when you look at this, we're talking about subtract divides, which really difference quotient sounds much more intimidating than that. Therefore, making it really, really weird that they use difference quotient. Anyhow, here's the two types of difference quotients that we've looked at. Apparently my green marker is dying, but here's the two types of difference quotients that we looked at earlier this year. And we're going to use these a ton in the second chapter where we're looking at derivatives. But realize this all comes down to when you find the slope between 2 points, you subtract their y values. Well, our 2 points here is I have an x value and a y value for the first point. And then I have an x value and a y value for my second point. So really, this is just y, I guess that's y2 minus y1 over x2 minus x1. It's the same thing down here, except our first point is x, and of course the y coordinate of x. And then the next point is just a little bit farther along. Just a little farther along. We're going to say it's the same x value, but just plus a little bit more. We use the letter h for this often. Sometimes we use delta x just for how much is the x value changed. I need another parenthesis there. But that's where these difference quotients come from. And here's what we do. Basic math. That's it. Believe it or not, from this example, if you plug this in, 0 for h, you would get exactly 0 in the numerator and 0 in the denominator. Now, how exactly is this a difference quotient? Well, it's just like the second example that I had up on the board a moment ago. Technically, that's the function with x plus h in there. And this is the function for just f of x. That's why it's called a difference quotient problem. We'll learn how to write them, how to solve them, what they interpret to be, a simplified version of that. But right now, what we need to do is just use our basic math skills. And I'm going to encourage you to use GermDOS, use your grouping, exponents, radicals, multiplication and division, addition and subtraction, using all of those in the proper order just to simplify this problem. Here's the order in which you should go. First, because they're grouped and there's an exponent there, let's just FOIL or multiply out x plus h squared. Next, we'll multiply or divide. In this case, that means multiplying 5 times this set in the parentheses, distributing, we could say, 5x plus 5h. Don't forget to multiply it out, distribute it to both terms. Finally comes subtracting and adding, if we have any adding there. The first thing we're going to be subtracting is make sure you subtract every term in the parentheses. That means distribute the negative sign to each term. The second thing that subtracting can mean is this. When we look at that huge, ginormous numerator, you'll notice that some of these are similar. I have x squared and I have minus x squared. Go ahead and subtract them out, and what do they equal? 0. I also have 5x and minus 5x. So when we combine those or subtract those, they equal 0. And then also we have negative 7 and positive 7. And those will also equal 0. That is subtracting. Now here's my big tip for you. When you do these types of problems, when you look at that second function, x squared plus 5x minus 7, if you're doing this right, every single part of this second function should subtract out to equal 0. Every bit of it. And we see the same thing here in this term. Every one, the x squared, 5x, and 7 all subtracted out, leaving us with what we have on the bottom there. And like every single method when we're doing these limits analytically, we're always dividing something out. By the way, if h is approaching 0, you're going to divide out factors that are h minus 0. If h was approaching 5, you divide out, x minus 5. If you had h approaching negative 3, it would be x plus 3 that you divide out. We're just dividing out an h here from the top and bottom. Then plug it